How's everybody doing today? Man, that's horrible. That's really horrible. Well, I can say I'm doing awesome. Happy to be here. So a little bit background about me. He gave you the introduction. I also work for a company called Expansia, where what the main talk that we're going to talk about today is how we're trying to solve problems in government, in particular for the US Air Force. So the topic here is called the journey. And I should have put up there a continuous journey as well, because that is exactly what it is. It's a continuous journey. So you can find me on Women in Linux, everything social at Women in Linux, Instagram. I don't have a Snapchat, I'm sorry. So if you were looking for anything live, I don't snap. But everything Women in Linux, LinkedIn, and so forth. So let's get down to it. So we're going to talk about, this is a good segue for Terraform. My journey with Terraform and things that I had to do, and then things that the team as well had to do to get Terraform installed on-prem. We're in an air-gapped environment. So when I say air-gapped, I mean there's no internet connection. Think of it as you're sitting in a trunk with your laptop trying to deploy Terraform or console or anything like that, and with a straw to breathe out of. So that's the picture I want you to paint, and have that in your head the whole time. All right, so we're gonna get right into it. So the environment that we're in, we're deploying VMs, sometimes from templates, sometimes they're manual installs, sometimes they're just a clone of something. You may have Puppet modules that we have to deploy. The Puppet modules are based on NIST standards. Anybody in here familiar with NIST standards, compliance is code, just so forth? Cool. All right, and then sometimes things come up and you have to make manual changes. Sounds familiar? Anybody in here still making manual changes? Probably, maybe, could be. All right, and then also we have a multi-environment. And when I say a multi-environment deployment, meaning that it could be on-prem, it could be in the cloud, it could be something with OpenShift, it could be anything. So how do you prepare workers and train people on something in this type of environment, and have consistency and not have drift in your configuration, drift in your security, drift in your patches, and so forth. So the manual testing after deployment, we want to get rid of that as well too. So when we're talking manual testing, having the mindset of manual testing for security, manual testing for your configurations with Terraform, Vault, console, all those things we want to get away from manual. All right, so some hardships that we've had and are still going. We're still pulling apart I guess the onion, you could say that. Logging into VMs, making changes in productions, long approval processes. We'll go into this with Sentinel. Monolithic applications and those dependencies. Having monolithic applications where we're deploying out to, we're using monolithic applications as we deploy, but we want to break those up into microservices. Again, we're talking DevSecOps and being siloed. You may have one team that's doing security for a particular group versus security being brought in from the beginning all the way through, and having better team collaboration. As we see with being siloed, there's not a lot of collaboration with a lot of teams sometimes, and sometimes there are. All right, so we talk about government transition. And this is where we're starting to get into the meat and the potatoes. All right, we want to start getting away from having the silo teams and pushing teams internal. And you could think of this like this. You have an Air Force, US Air Force. Imagine how many teams, IT teams you have in that particular environment. Imagine how many teams you have in your environment where you're not constantly talking to each other. You may have one team, say, in one section doing DevOps, or you may have another team over here doing DevOps, but you're using two different stacks. There's not a lot of communication. So we want to push more to have internal team collaboration because that leads for quicker deployments, better feedback, also alignment as well. Oh, my bad. Sorry. Also, we want to make sure that we're walking through and having our pipeline as we test through as we deploy, we're having testing throughout our pipeline from beginning all the way to the end of that. We want to make sure that we handle testing. And testing is also not just testing to making sure the application works, but functional testing as well too. Testing of your code, testing of everything throughout the process. So I put this here to define what system architecture looks like for us at this current moment. System architecture for us, if you go online and look, I've made some changes and I'll highlight some of those changes in here. One of the changes that I did put in here was DevSecOps. That wasn't necessarily in the system architecture diagram that I followed. And also having architecture development phases. And I say that with the meaning of when you're doing a deployment, especially if you start talking about moving from monolithic or moving from a situation where you're going into microservices or deploying on-prem or multi-environment, you have to have to me, not necessarily a generic, but a baseline. And that baseline can be, hey, I know I need to have some security testing in there. I know I need to be able to create my machine images from the beginning to end, testing those machine images, also testing for security, also testing for where I'm storing those at, what type of, I guess you could say, revision repository, how often am I going to deploy these machine images, and what kind of revisions am I going to have for those? So continuous security. For us, it is deploying the VMs using a template. You can use Terraform for that, or you can also just use Terraform and just deploy your actual infrastructure. Right now, we're currently deploying against just the infrastructure to VMware, using Packer to do our builds, and I'll discuss this a little later in this talk, where we're going through and saying, hey, we're going to take Packer, we're going to set up the Packer repo, we're going to template out Packer, and then we're going to deploy our images from there. All right, so also with that, we'll have security injected from the beginning. So instead of having security at the end, security can be put in the beginning with Packer and also security from scanning your RPMs, scanning your ISOs, also your config files in terms of static code analysis and so forth. And so this is also where we get into doing policy as code. We use Terraform Enterprise, so policy as code is very huge for us. So a lot of the upcoming announcements that just came out with Terraform is something that we really need, and I'm excited about those things. And the last but not least, throughout our entire pipeline is always having feedback to the teams and always having feedback into Jira. So as you deploy throughout the process, there's feedback loop and quicker feedback loops because now you have that attached to Jira. Right now we're setting up where we can have our Packer deployment or machine image deployment tied into Jira. So this is just a wild idea concept that we came up with. Because we're using Red Hat, we're looking at, hey, we need to have the satellite server pulling in all the ISOs, all our packages, and so forth. From there, we'll roll into scanning those things, scanning those packages, scanning those ISOs. If we find any vulnerabilities in those, we immediately know up front there's an issue. So now we don't move forward in our pipeline, we fix that. So now we've implemented pulling in those packages and implemented security up front. The next phase that you see is We have GitLab and we have Jenkins. Now, you may ask yourself, why do you have both of those? I told you it's a journey. So as we go along that journey, we will pick GitLab or we will pick Jenkins. But right now, we have both. So how would that look? Well, a file is a file, right? So for us, it's just as simple as writing, you don't necessarily have to have a bash script, but any script can be called from Jenkins or any script can be called from GitLab. So once you get into this situation, now we're taking it and we're gonna start checking our code in and then kicking off a build. And that's where you see number one, where we start using Packer. And Packer has the ability to build out Docker containers, AMIs, also OVAs. Then we move into phase two. And phase two is saying, hey, if I'm on-prem, I can use Terraform to deploy to wherever I need to go, but in this case, we're on-prem. Or I can use, in a local situation, I can use Vagrant. The next thing that you see is stigging. So when I'm saying stigs, I'm talking about NIST standards and security as code and compliance as code. So here we can use PowerShell if we have a Windows box. We can also use Puppet, or we can use Ansible scripts. And then the next thing you have is Twistlock, or Nexus IQ, or ACAS. So with those three, some features that you get in Twistlock, some features that you don't get inside of Nexus IQ. But what you do get out of all of those is the ability to now apply some policies within those particular items and saying, hey, if you pass or fail after I do a particular scan, and I can define what that scan is, then you move on, and I have what I consider a complete machine image that has been secured from beginning all the way to the end and available for use. You can even take that one step further and say, hey, let me define what an application would look like and apply an application on top of that as well too, and provide that in your staging state or in your staging environment. And then say, okay, well, I've deployed the image, I've stigged the image, I've deployed the VM, and I've also applied the application on top of that. And throughout that process, in your staging process, now you would see that you have security implemented all the way from beginning to end. And so with using Terraform for that, and I'll show you this here next. So policy as code, we want to implement this as we talked about just in that image policy as we want to create it. We want to be able to deploy to different environments, quicker time for responses in terms of failures, in terms of successes, knowledge transfer through code, how did you do it, being able to share with other teams, and also working with bringing ops and developers together for quicker feedback loops on deployments. So as we talked about earlier, we heard about Sentinel. So how does that apply in our world? And when I say our world, is policy as code is very huge, and also something that is ongoing every day. So as you see at the bottom, and I talked about this, checking your code in, building it out, whether it's a Docker container or a VM, and then using Sentinel to say, hey, I can deploy to the staging environment. If not, I'll stop and say I can't deploy to that staging environment, but I have that ability now to say yes or no. And then also I can go back and say I want to scan that environment as well too. And then also give that feedback loop to Jira. So that's what that looks like. Also on this one here, one of the bigger projects, one of the bigger issues in this project is having a multi-environment. Well, with that multi-environment, I'm not sure if anyone is here played with Azure Stack or AWS Outpost. Outpost is actually coming out, I think, roughly around September, October frame is what they were looking at. But as we prepare to go forward, we want to also be prepared to play in those environments, and we will have that option, and we will have that pipeline already set out. So Terraform Enterprise. The advantages that we have seen is, one, we're able to hold state. VMware, we can't hold state unless you're using vRealize, but then there are other issues that go along with that. Control policies on the environment. Also, we need to have the ability to audit. Now, if we have those policies that are written out in code, we can now see who was actually able to move that environment into, well, push the button on the environment to say, hey, we deploy it to staging or we deploy it to production. The next one is see who actually did what and have that feedback in Jira. Super important. We're also using Vault. So we're using Vault Enterprise for a couple of things. One, we need PKI integration. The other one that we need is we need it for Terraform. And the other one that we also need is for controlling logging into servers. So when we're talking about logging into servers, in some cases, you may need someone to log into a server depending on, if it's a monolithic application and it's been around forever and that's just what they've been used to. You want to get away from that, but at least we can have that controlled on the Vault, saying that, hey, you only had 30 minutes to log in and check and see what was going on and then log out. So we can put that on the Vault. The other thing we do here is also tying that back into Kerberos or LDAP, or even in this case, Windows, which is still underneath Kerberos. So problems and collaboration. So let's get into this. So I had the joy of working with Terraform Enterprise on-prem and working with Amanda, Jennings, and Todd. So I give you my issues that I had and how we came around and actually got this to work, and we're still continuing this process as well too. So some of the issues that I had to actually set up an environment, and I installed Terraform Enterprise at least 40 times. Why? Because out of the 39 times, it didn't work. And it's no shade to anyone here at Hashi, but it was just something that we had to walk through and figure out. And some of the things that we had to figure out was what type of Docker version were we using. Were we using Red Hat native Docker version, or were we using Docker version from the Community Edition or the Enterprise Edition? What OS? Is SE Linux turned on? If SE Linux is turned on, what do we need to have set up in SE Linux? Object stores. Were we using the object store, or were we using the actual mounted directory for Terraform Enterprise when you're doing the install? Is my vault set up correctly for my external vault, or do I need to use the internal vault when I'm doing this? And we're also in an air gap situation, so anytime, once we got finished, the providers that we needed to already be wrapped up and on either a Docker container or wrapped up installed in a tar file. And then the next big phase was, how do we automate everything that I just talked about and install Terraform from checking the code in to GitLab all the way to a deployment. So what does that look like? So this next one, you probably can't see it, but in this, what I talk about here is my matrix that I set up, and the matrix, and I'll tell you about it. It's 3 different versions of Terraform that I went through, 4 different versions of Red Hat that I tested this on, setting up different IP tables in terms of what particular ports needed to be open. When you install Docker writes to those IP tables, what particular ports needed to be open on that, what bridges were open, Vault. When I talk about an external vault, setting up your external vault and then connecting that back to Terraform, was that configured correctly as far as the app role, also the internal vault as well too. The next part of this was, did I set up my database correctly? Because there is a database involved with this. So was that set up correctly when I was doing my install? And also, did I have permissions to read and write? And last but not least, disk speeds. That was actually a key factor in this, was finding out when we were setting this up, the disk speeds actually slowed down the install of Terraform and actually failed. So we went through and tested the disk speeds for that. So The summary of those issues is now after communicating back and forth with HashiCorp, we actually got it stood up. We also did a lot of collaboration back and forth on what issues that we had, and some of the issues that we had were actually implemented into Terraform Enterprise. So I'll take the yay on helping someone else on their next deployment. And the other one is, it was a shared environment that we set up so that we can all test this back and forth and share this with the actual team, so we can go forward and say, okay, yes, we installed Terraform Enterprise, it does work in this, we can use this. And also automated installs. All right, so that was the team collaboration on that with Hashi and Expantia. The next one is worker team and training are some of our issues. So as you saw on the actual slide with the image policy, you saw a lot of tools. And we can all agree that when you have a lot of tools, that's a lot of learning and that's a large learning curve. So how do we get around that learning curve? How do we take care of each other as we do this? Group learning, with us as a group and with any group, I actually strongly recommend that you learn who you are as a person in terms of learning, because that really is going to drive how you learn. If you're a person that likes to see videos, or if you're a person that likes to sit down in groups or whatever, that's going to drive your team, and that's very important. Sorry about that. The other one is emotional intelligence. That was super huge with us in terms of, the successes and failures. I'm going to say this, and you can take this with a grain of salt, but don't beat yourself up or don't have fear of failure. You're going to fail. I mean, I installed 39 times and failed, so I was relentless. So just to give you an idea. The other one is having support with your team, having the management buy-in. We had to have team buy-in. We got to have management buy-in. You also have to sit back and have leadership, allowing people to go out and understand how Vault works, how Vault integrates with this, how console works, how it all integrates with each other, how does GitLab work, how does all these different tools. I think we're up to, 10 tools right now, and potentially could be more tools. So having that understanding of how each tool works is super important. The next one was daily team building and growth, and this is really key right here. Having the ability to say, hey, we did this with Terraform, and this is super huge in communicating in tickets in Jira, exactly what you did, screenshots, the whole nine. Remember, we're in an air-gapped environment, so that's a lot of writing and translating that out into a Jira ticket. Not super fun, but you actually need it. And that's how you build around those errors and build around that team. And that's what we wanted to do, was be able to shift our metrics left. When I say that, actually Paul talked about this, is how do we scale, right? So when we're talking about scaling, we're also talking about we have a lot of teams. And we have a lot of teams that we're working with. So we have to be able to, one, get feedback from Terraform immediately when something failed. We also need to know that if a package came in, if it didn't pass or it did fail, we need that immediate feedback. But on top of all of that, when we do deploy and we do have applications out there, we need to make sure those applications work. So things like console and observability and microsegmentation really play a key instance, because we do have multiple teams. So for one of the teams that we do have coming into the fold is they wanted to be able to test 10,000 concurrent connections on a Kubernetes cluster and making sure that they're getting those metrics back. Well, goes back to that system architecture talk that I did earlier, is better the architecture design. How do you design for that up front, What does that look like? What are you currently doing? How can we change those things? These are the things that we're going to use as we go forward, and also for console and observability to give us metrics on what's going on, being able to trace where, hey, we deployed, but now the whole system is shutting down on us. How can we trace that back? This is where we start introducing that. And also, remember, we're on the Kubernetes cluster, so we need to have some namespaces set up where we're dividing up different projects and so forth. So future goals. All right. So these are the things that I think are future goals for us. My whole team may or may not agree, but this is what I'm seeing. A multi-cloud strategy. There is and this is how Hashi comes into play with this. There is an actual article out there from the government. I don't know if everybody heard of the JEDI project. Well, the JEDI project in the States is a $10 billion project. And that $10 billion project was brought up between Amazon and all the cloud providers that they bidded on. And I think the actual top, who's going to get it is going to come out and say in August or so. That's what they're saying in the paper. But with that project, there was one sole winner for that for $10 billion. The next one is we're going to do CTE. They're actually doing a CTE project, and that's going to be a couple of billion. And so I think Hashi looks really good for that. The next one is building cloud native infrastructure. The main one that is really on this one that I'm super excited about is KubeVirt. What KubeVirt allows you to do is take a monolithic application, deploy it onto a Kubernetes cluster. That is super huge. And being able to get off of something that's on a bare metal machine and move it over to a VM and move it over to a cluster. So what you see here are things that are on the horizon. This is how I see Hashi flowing with us from Console, Vault, and Terraform. And then as we continue to grow along, I'm sure there'll be other things that we want to implement. So together, this is what I see. Hashi, Airforce, and Expansia. I'm Tamika Reed. Hope you enjoy it.